Hello everyone, this video is going to be about the triangle congruence. Now here you are going to be learning about 3 more postulates, but in this video we will only look at the first two, that's ASA and AAS. By now you know how to interpret these words. ASA means angle side angle and AAS means angle angle side, and that HL we will look over it for now. In the next part of the video, we will learn about that too. This is going to be chapter 4, lesson 6. So let's start by knowing what is an included side. You have an idea about included angle. Included angle means the angle between the two segments which they're talking about in a triangle. Now, an included side has the same idea of an included angle. Included side is the common side of two consecutive angles in a polygon. So, in fact, included side is the line which connects the two angles which we are talking about. So here, angle P and angle Q. So the included side is the line which is connecting both of them, the segment which is connecting both of them. So PQ becomes the included side. So for example, if I may ask you what is the included side for R and Q, for angle R and Q, which is the line which is connecting angle R and Q? Segment RQ. So segment RQ is the included side for angle R and angle U. So keeping this idea in mind, that is the included side, let's see what does this ASA postulate say. So angle side angle congruence. What does this angle side angle congruence say? If two angles and the included side of one triangle are congruent, so for example triangle ABC, if two angles, that's angle A and angle C, are congruent and the included side. I forgot to tell you the included side. So two angles and the included side is congruent to two angles and the included side of another triangle. That means both of the triangles are congruent. In simple words, if you have two angles on either side and the line connecting both of them are equal to another triangle, that means both the triangles you can say are equal. Listen to these words carefully. In a triangle, if two related angles and the joining line between the two angles is equal to another angle, both the sides and the included side, that means the two triangles are congruent. Let's see. This is angle side angle congruence. This is another one which is AAS. So ASA said that two angles and the included side. Now you can keep it in mind this way. You can see that two angles are on both sides. Okay, and the connecting line is in between. So two angles and the connecting line in between is equal, means both triangles are equal. Not to confuse you with AAS, this is angle side, which means two angles and a non-included side. Now, if you know what is included side, the opposite of that is non-included side. So if I ask what is the included side for angle G and J, which is the included side for angle G and J, the included side is GJ, the line GJ, the segment GJ. So the opposite of that is non-included, which means it can be GH or HG. It can be any. It's not necessary, it's only going to be this. So the angle side theorem says that if two angles and a non-included side of a triangle are congruent, means are equal to another triangle, that means both the triangles are equal. Both the triangles are congruent. The first postulate said that if two angles and the connecting line are equal, that is the included side are equal, then both the triangles are equal. Now this theorem says that if two angles and the line not connecting them are equal, that means both the triangles are equal. You can write down those easy words which I just said now, so that it won't confuse you and you can just revise in the easy way rather than keeping all these difficult things in mind. Okay. Now let's see what are we going to do with this ASA and AAS theorems. Determine if you can use ASA to prove triangle UVX is congruent to WVX. So this is the figure given to you. So what are they saying? Just check if you can prove that triangle UVX, that's UVX, is congruent to WVX, and they told you to use ASA property, which means it should have two angles and the side connecting them. This is what we need to find out, whether in this picture do we have two angles and the line connecting them. That's what we need to find. Okay, now here they already gave this angle is equal to this angle. Okay, now look at triangle WVX. Look at this triangle here. This triangle has two sides, two angles. They already gave us two angles. Okay, but in this triangle they gave us only one triangle, one angle, and they already said they both are equal. Now to find out whether this triangle is equal to this triangle, we need two angles and the included side. So already in this triangle they have given us two angles, so which means using this we can find out the value of this angle, right? You know, these are linear angles. They're angles on a straight line. So if one part of the angle is 90, the other part is going to be 90 as well. So I can say this angle UVX is also 90, right? So if this is 90, this is also going to be 90 because they're angles on a straight line or linear angles. Another word for angles on a straight line are linear angles. Okay, now we have this angle equal to this angle equal to this. Now we need the line connecting them is equal or not. So which is the line connecting them? The included side is this, Vx. Now by the reflexive property, you know that Vx is equal to Vx. It's always like that. This line is equal to the same line because that line is being shared by both the triangles. So let's start by writing the steps. Now, triangle U, we always start by using the information which they have given. Okay, so the information given is UVX is congruent to triangle WVX is already given. Now, I can say that this is already given too, that angle UXV is equal to WXV. They're already given. So I can say since WVX is a right angle and it forms a linear pair, so angle UVX is 90 degrees as well, right? I can say because now this is the way I wrote. You can write it in your own words. It doesn't matter. It's not necessary that you need to use the same words. No, it depends on how you use the words. Okay, so there are many ways. The thing is the main idea, you need to just interpret that in words. So I am saying triangle WVX, okay, WVX is 90 degrees. So that means angle UVX is also 90 degrees. That's because they are linear angles, linear pair of angles. So in other words, I can also say angle UVX. Now, why am I referring to UVX? I can say angle V equals angle V because both of them are angle V. But then anyone might get confused, which angle V are we talking about? So that's why we name it in this order. Both means angle V, but we need to give the angle the proper name. So UVX is equal to angle WVX, or it is congruent, right? Because both of them are 90. It's up to you how you are writing. So, and then we have the two angles. So we are proving the final one is this. XV or Vx is equal congruent to Vx. That is because of the reflexive property. Now, have we found that two angles and the included side of both triangles are equal? Yes. So we could say triangle UVX is congruent to triangle WVX by angle side angle property theorem or postulate. This is how you need to use. Yes, it is a bit It needs a bit thinking, because as soon as you see the picture, you need to understand what kind of information have they given. It takes time, but then practice is the only key which can make it perfect. So practice. Fine. This is another question. Now determine if you can use ASA, again angle, side angle, which means two angles and the included side, to prove triangle NKL. Follow the order. NKL is congruent to angle LMN. Now, what is the information which they have given us? They have just given us that KL is parallel to NM. That's all they gave. They did not give us any other sides are equal or not. So, even if we say KL is equal to NM, we need to find two angles, which neither of them, they have not given any of the angles, right? They did not say any angles are equal here. The only one we can derive from ourselves is ln is equal to ln because of the reflexive property only. Other than that, we have no information. So this triangle, the congruence cannot be determined by using ASA, as enough information is not given. For ASA, the two angles and the included side should be equal. They did not give us any information. This also we derived it by ourselves. ln is equal to ln. We found it out by ourselves because we already know. Only that can be determined. So enough information is not given. That's why we could say that it cannot be determined. Okay, let's look at one more question. Use AAS. Now this is angle, angle, side. Now what did this theorem say? If two angles and the non-included side is equal, that means the triangles are congruent. This is what AAS said. The two angles and the non-included side is equal, then the two triangles are equal. So given JL bisects angle KLM, this is the angle. Now this word bisect, we have already taken it many times, means divide equally in two parts. Divide equally in two parts. Then angle K is equal to angle M. Prove triangle JKL is congruent to triangle JML. So triangle JKL is congruent to triangle JML. Information given is JL bisects KLM. Now what can you derive from this idea that it is bisect? Now if there was an angle at L, that means it has divided the angle L in two equal parts. If I interpret in numbers, for example, if L was 50, now it became 25, 25 each. Okay, so let's start by, this is called a flow chart. Do not worry, they're the same steps of writing the proof, but only that they have given them in the flow chart symbols, that's all. So the first information given is JL bisects angle KLM. This is already given. Now, what happened when JL bisected angle KLM? What can we say? We can say that angle KLJ is equal to angle NLJ because it has bisected angle L, which means it is divided into two parts. So as I said, if it was 50, that means this is 25 now, this is 25. So both the angles are equal. So I can just say that KLJ is equal to NLJ, or you can even say JLK equals JML. JLN. It's the same. It depends on how you look at the figure. That's all. So because why did I say both the L's are equal? Because of the definition of angle bisector. The angle bisector says if an angle is bisected, it is equal divided in two equal parts, which means both of the angles are equal. Now, from this, also they have given us the information that angle MK is congruent to angle M. So this is another information they have given, which is given. We are not going to connect these two because they are not related. This is another information which is given, so do not connect them. Now from this, what can we say? Now JL is congruent to JL, we know. And by which property is that? By the reflexive property of congruence. Okay. Now I can say that from all these three, now what is that? What we are using? AAS. Did I say two angles are equal? I said angle K is equal to angle M, and this angle L is equal to each other. So we have two angles and the side should be none included. I cannot take KL because that's the included side. So I need to use JK or I need to use JL. So easy to take JL, as JK they have not given us anything. So I can say JL is congruent to JL because of the reflexive property of congruence. So as a result, triangle JKL is equal congruent to triangle JML because of the ASA property. Sorry, AAS property, AAS, angle, side, angle, and the non-included side. So that's what we did here. We said two angles are equal and the non-included side is equal to the other triangle. So both of them are congruent. Let's put these ideas into practice. Let's see. Hopefully you will understand it much better. Now, if you have fixed in your mind that no, I don't understand, then definitely you're not going to understand it. But if you think, yes, I can try, means you can do it. Okay. So this question here, determine if you can use angle, side angle. So from this itself, you need to remember, get to know angle, side angle means they're talking about two angles and the connecting line between them. So we need to prove that here two angles and the connecting lines are equal. Okay. So let's say they have already given us triangle VRS is and triangle VTS. So we need to prove triangle VRS and VTS are congruent given that VS bisects. Here goes the word bisect again. So VS is bisecting angle RST. So it has divided this angle in two parts. Now, can I say this angle is equal to this angle because it is bisected? The picture is not clear, I think. I don't know. Let me make it a bit bigger. Okay. Now, because line VS, it has bisected which angle? See this middle letter. This middle letter is the angle which we are talking. So angle S. So it has divided the angle in two parts. Now I could say this angle is equal to this angle, right? So first thing, write down the given information. Okay, so it is given VS bisects angle RST and it is also bisecting angle RVT. This angle too, see? This angle too is bisecting. So I could also say this angle is equal to this angle as well. Just now I explained how bisecting works. Okay, RST and angle RVT is given. This is given. You can use a two-column proof, you can use a flowchart proof, just like the example I showed you before, or you can use a paragraph proof. You can even just go on writing about the proof. It's up to you. Okay, unless they don't specify. If they say write a two-column proof, you must do, else it's up to you, however you want to. So VS bisects RST and RVT is given. Now because of this bisecting, what can I say? I can say that angle TSV is congruent to angle RSV. Also, I can say angle TVS is congruent to angle RVS, right? Do it slowly, you will understand it. First, write the information given, then find out because of this bisecting what happened. What happened because of the bisecting? This angle became equal to this angle. This angle became equal to this angle. So that's what we are writing. Instead of writing angle S equals angle S, we are saying, we are just following an order, that's all. We are saying TSV is equal to RSV. If you want, you can even say VST. either you go in this way or you go in this way, doesn't matter. Okay, now why did we say this? Because of the definition of bisector, angle bisector. Okay, now what's the next thing? Now we are using ASA, which means two angles and the included side. So here already we proved that two angles are equal to each other. So what we need to prove is the included side equal or not. So here we could say SV is congruent to SV because of the reflexive property of congruence. Reflexive property of congruence. So which means triangle VRS and VRS is congruent to triangle VTS because of angle side angle postulate, right? So this is how you need to prove. Always think what kind of proof or what theorem are we using. It's ASA, which means two angles and the included side. So if we can prove that two angles and the included side are the same, that means we have already done our proof. Alright, moving to next question. Triangle DEH, so they're talking about this triangle DEH and triangle FGH. The information given to us is only these two are parallel, that's all. Now, from our mind, we can say they did not give us anything, so only we can derive that this angle is equal to this angle. That's all we can say. We cannot say anything else because they did not say anything about corresponding sides. They didn't say anything about corresponding angles, not the corresponding side. They did not say anything about corresponding angles. So the information given here is not enough. So you can write not enough information is given about corresponding sides of congruence. So which means we cannot determine that we cannot use ASA here because we just by ourselves find out that one pair of angles are equal. What about the other pairs and what about these sides? They did not give us anything, so enough information is not given. Okay, now let's find out whether we can we can complete this flowchart proof. Okay, so use AAS, angle side, which means two angles and the non-included side to prove the triangles are congruent. Given R and P are right angles, QR is parallel to SP. Proof, okay, the triangle QPS is congruent to SRQ. Fine. They want you to fill in this place. So reflex property of congruence, which is the reflex property of congruence? QS. So we can write here QS is congruent to QS. This is the reflexive property. Okay, this is given. QR is parallel to PS is given, which is the alternate interior angles theorem. Now, alternate means opposite, interior means inside. Which one are you going to use to prove that it is alternate interior angles? We can say this angle is equal to this angle because of alternate interior angles, right? They are alternate interior angles. So they just want you to write a pair, that's all. So here we could write triangle RQS is congruent to angle PSQ. Now follow the same order because it's must. So if you're saying RQ, that means it should be PSQ. Okay, so this is Okay, that was about alternate and interior angles theorem. Now, what about this one? How can we say that angle R is congruent to angle P? They both are 90 degrees. So, which theorem are we going to use? 90 degrees means what kind of angles are they? They are right angles. So, we could just write there right angles, congruent, right angle congruence theorem, in fact, because they're congruent. They just showed us that they're congruent. So, it's going to be right angles congruent theorem. That's because both of them are equal and both of them are 90 degrees. So 90 degrees means it's right angle. It's, in fact, this proof is like a mixture of what all you have studied, all the things which you have studied from the past year. That's from the beginning of geometry. It's like a whole proof, a whole mixture of process of all to prove everything. So triangle QPS is equal to triangle SRQ by theorem? Which theorem did we use now? We used two angles and the non-included side. See, two angles and the non-included side. So which means this is going to be angle, angle, side. Just that you have to give what kind of theorem you proved. That's all. In fact, completing flowcharts is much easier than writing our own proofs. All right. So that was all your lesson about, and hopefully you will understand it much better. I think if you don't understand, there are more questions in your textbook to do, so you can do them and you can confirm your answers with me if you want to. So till we meet in the next part of the lesson, uh, try to practice and understand the lessons. So we see you all in meet you all in the next video.